Okay, in our previous class, we started chapter 2. Chapter 2, we give some definitions about angles, lines, and parallel. We define what the meaning of angles, what the meaning of line, what the meaning of parallel line. We give definition for and theorem related to the vertical angle, related to interior angle, exterior angle, corresponding angles, co-interior angle, alternate interior angle, or alternate exterior angle. All these definition we give in our previous class. And also the congruent of triangle. What is the meaning of the congruent of two triangle? And we say that we have four theorem for the congruent triangle. We have S when the three sides are equivalent. S when we have two sides and the angle between them are equivalent to the two side and angle, then the two triangle are congruent. And also angle, side, angle, ASA. Two angles and side. Two angles and side. Maybe the side between the two angle or not between the two angle or not between the two angles. So we have four theorems for congruent triangle. And also we define the isosceles angle triangle, and we said that the base angle should be equal for the isosceles triangle. And because of the proof have a problem, we have two problems in this proof. One of this problem is using proposition 9 while we are proving we are still in proposition 5. And also we use that the line is divided the triangle into two triangles, and this is not within the axiom. So this is why we have the but in case that the line intersect one line or one side of the triangle, it should also intersect the second line. So we stop here in our previous class. Okay, another one definition, what we call is a circumcenter. Circumcenter. This point, the circumcenter, if I have a triangle A, P, and C, now for the first side, PC, for example, I will divide this side at the midpoint, which means this part will be equal in length, this part, and this angle is 90 degrees, which means I will draw a line from the midpoint perpendicular to PC or orthogonal to PC. Same here, I will divide BA into two equal parts, and then I will draw from the midpoint a line perpendicular to BA. Same for the third line, AC. I will divide this segment into two equal parts. Okay, so I have a midpoint here, F, and from the midpoint, I will write another perpendicular. So the circumcenter, these three lines will intersect in one point. These three lines will intersect in one point. This point, we call it the circumcenter. The circumcenter. So the perpendicular bisectors of the side of the triangle intersect at a common point called the circumcenter of the triangle. The circumcenter, which means that I will draw for each side, I will divide each side or bisect each side into two equal parts, and I will draw from the midpoint perpendicular line. So the three perpendicular lines will meet in one point. This point, we call it circumcenter. For this circumcenter, if you make it a center, as a center on the circle, and you make your radius as the distance between this point and any point of the triangle. I mean, the radius will be this line. Will be this line. This is the radius from here. From this is the center. Is the circumcenter will be the center of the circle. And the length between the center the length between the circumcenter point and any point of the triangle, maybe P or A or C, is the radius. If you draw a circle using the center point and this radius, this circle will go through the 3 points of the triangle, the 3 points or the 3 vertices of the triangle. It will go through the 3 vertices of the triangle. We call this circle is circumcenter. We call this circle is circumscribed circle of the triangle. Circumscribed circle of triangle. The circle with center at the circumcenter and radius out to one of the vertices will pass through the other vertices. Will pass through the other vertices. This circle, we call it circumscribed circle. Circumscribed circle. Another one point, we have the orthocenter. Here we have the circumcenter. Here we have the orthocenter. Now the altitude for any triangle, if you draw a line from the vertex, here, from any vertex, and perpendicular to the opposite side, we call this one altitude of the triangle. Altitude of the triangle. When you draw a line from a vertex, one vertex, perpendicular to the opposite side, we call this one altitude. So now I can draw another altitude from C and another altitude from A. Each time is perpendicular to the opposite side. The 3 altitudes will intersect also at a common point, at one point. This point, we call it orthocenter. This point is orthocenter. So the orthocenter is the intersection point for the altitudes of triangle. We call this one orthocenter. Okay. Example. Now I need to give 2 examples before going to another definitions. Here we have in this diagram, you have BQ is equal in length to BR. BQ equal in length to BR. And you have this angle BQR, if you call it angle 1, and BRX, if you call it angle 2, R equal. PQ is equal in length to BR. Angle 1 is equal to angle 2. First, you need to prove that QY is equal to RX. QY is equal to RX. How can we prove this one? I need to prove that QY, this line, is equal to RX. The 2 triangles are congruent. Now you have the triangle. You have the triangle PQR. You have the triangle BQY. This one is congruent to the triangle BRX. BRX. This one. I will make a congruent between these 2 triangles, BQY, PRX. BQY and BRX. Okay, what we have, if I need to do this, so what we have? First, we have that from what we given information, we have BQ equal to BR. This one given. Also, what we have that angle 1 equal to angle 2. Also, this one is given. You have also that the angle QBR is common. as common. The angle, this one is a common angle. You have angle 1 equal to angle 2. PR is equal to BQ. This angle is common. So the two triangle, by using ASA, by using here, by using ASA theorem, then you have the two triangle are equivalent. The two triangle are equivalent. So what we can conclude from the equivalent is that QY equal to RX. So that we have QY equal to Rx. QY equal to Rx. Okay, now we need to prove the second one. We need to prove the second one. Xn equal to Yn. I need to prove this part. Xn equal to Yn. We already proved that Qy equal to Xr. Now I need to prove that Xn equal to Yn. Congruent to the triangle X and Q. Can we make this triangle Y and R congruent to X and Q or not? Q equal to YR. XQ equal to YR. Now I have previously here, I proved that the triangle BQY is congruent the triangle BRX. And we conclude that XR equal to QY here. But also we can conclude that PY equal to BX. PY equal to BX. So here you have and BX equal to BY. Now, if I subtract, because you have as a given information that PQ equal to BR. Now subtract equal. I make that BR subtracted BY will be equal to BQ subtracted BX. Because BR equal to BQ, BY equal to BX. Okay, BR minus BY is YR. BQ minus BX is XQ. XQ. So we will have that YR equal to XQ. Now we can make the two triangles are equivalent. Y and R should be equivalent to X and Q. X and Q. We have that the two triangle. Now we can conclude that the triangle Y and R is equivalent to the triangle XQ, X and Q. X and Q. Y and R is equivalent to the triangle X and Q. You have angle 1 equal to angle 2. You have YR equal to XQ. And you have, okay, in these two triangles, Y and R, this one, and X and R, we have angle 1 equal to angle 2. And we just prove now that XQ, this part, is equal to YR, this one. And you have these two angles are equivalent by 3 and 4 because they are vertical. 3 and 4 are equivalent because they are vertical. So what we will do is, you have that angle 3 equal to angle 4. Why? Because vertical angles. Vertical angles. So what we can conclude, that xn equal to yn. Xn equal to yn. So first step, I prove that PQY is equivalent to BRX or congruent to BRX. The triangle BQY is congruent to BRX. You have BQ equal to BR. You have angle 1 equal to angle 2. You have angle BQR is a common angle. So the two triangles are congruent, then QY equal to XR. QY equal to XR. Okay, now also from the same congruent, we can conclude that PX equal to BY. The side BX equal to the side BY. So now from BR, if I subtract PY, from BQ, if I subtract BX, the remaining will be equal to the remaining. This is notation, I think notation 4 or 3 for Euclid. So from this notation, you have that YR equal to XQ. YR equal to XQ. So now you can make the triangle Y and R is congruent to the triangle X and Q. X and Q. So we have vertical angle equal to vertical angle, 1 equal to 3, so 3 equal to 4, 1 equal to given information. And we, from here, we prove that YR equal to XR. So use angle, side angle, or angle, or here angle side, not angle side, angle side. So if you use angle side, then the two triangles are equivalent, and then we can conclude that xn equal to yn, equal to yn. Okay, another example here. I have this figure, and in this figure, we have that AB is parallel to FE. This sign means parallel. This sign means parallel. I have AB is parallel to EF, to this one. And AC is parallel to DF. PC is parallel to DE. Parallel to DE. We need to show that all 4 sub-triangles are congruent. The small 4 triangles, we need to prove they are congruent. So how we can do that? Yeah, maybe I can make it more clear for you. Okay. Okay, for these 2 triangles, we can look for angle 1 and angle 2. Also for angle 3 and 4. The triangles ABC and AEC. ABC and AEC. Okay, in these triangles, we have that first, the angles 2 and 1 are equals. 1 and 2 are equal. Why? Because they are alternate angles. Also, we have that the angles 3 and 4 are equals, also alternate angles. And AC is common side. So from this one we have, so the two triangles are by ASA. The two triangles are congruent. The two triangles are congruent. Okay, now by the same way exactly, you can prove the other triangles. You can prove that ABC is equivalent or congruent to ABD. You have this angle equal to this one, this angle equal to this one, and you have a common side. Also, you can prove these two triangles are congruent by the same way, We learned the circumcenter, the common bond for the bisector perpendicular lines, and orthocenter, the common point for altitudes. Now we have incenter. This is the common point between the bisector of the angles. The bisector of the angles. We mean if I bisect angle A and bisect angle B and bisect angle C, the three bisectors will be intersect in one point. This point, we call it in center of the triangle. In center of the triangle. For this center, if I take it as a center of a circle, okay, and if you take it as a center of the circle and you draw a circle where the radius is the you can draw a circle that the circle is intersect the triangle sides from inside. If you use this point as a center, you can able to draw. If you take the radius is the distance between one point and the sides and one side. So you will be able to draw a circle. This circle will intersect each side at one point. Will intersect each side inside the triangle in one point. So a circle is inscribed in a triangle if it intersects each side of the triangle in single point. In single point. We call this circle is inscribed circle. Inscribed circle. Measurements and area in Euclidean geometry. Now we will talk about the parallelogram and the area of parallelogram, the theorem of parallelogram. Okay, we know that triangle, with a triangle we have 3 points, non-collinear 3 points, 3 sides. So if I need to give a definition for quadrilateral ABCD, so I should have 4 points here. Okay, and 4 segments, A, B, B, C, C, D, D, A. So we have 4 points and 4 segments. The condition is to let these 4 points and 4 segments form a quadrilateral. First condition, no 3 points are collinear. I mean, no 3 points on the same line. No 3, you can find 2 points in the same line, but no 3 points on the same line. So no 3 of the points are collinear, and no pair of segments intersect except at the end point. I mean that each two sides will intersect only one in one of the endpoint of the quadrilateral or one of the vertices of the quadrilateral. Then in this case, we call that A, B, B, C, C, D, D, A are the sides, A, C, B, D are the diagonals. B, C, and A, D are the diagonals. For example, if we go for any, if you go for any quadrilateral shape, okay, if you go for any quadrilateral shape, if, for example, I try to draw this one, I have 4 points here, not on the same line, not the 3 on the same line. You have 2 on the same line, not the 3. So this is the point A, B, C, and D. So A, D, C, D, B, C, A, B are the sides, but B, D, this one are the diagonals. Are the diagonals. B, D, and A, C, we call it are the diagonals. Okay. When the quadrilateral can be called a parallelogram, it's called a parallelogram if AB is parallel to CD. In case that AB is parallel to CD, BC is parallel, which means that two opposite sides are parallel. Each two opposite sides are parallel. Then this shape will call parallelogram. We call it parallelogram. So now we have some theorems for these parallelograms. So this is the first theorem. This is the first theorem. Prove that the opposite sides are congruent. Prove that the opposite sides are congruent. Show that the opposite sides are congruent. Now we need what we have. This is a parallelogram. This is a parallelogram, which means that DC is parallel to AB, AD is parallel to BC. We need to prove that DC is equal to AB, BC is equal to AD. AD is parallel to BC, DC is parallel to AB. This is the given information. DC parallel to AB, AD parallel to BC. This is the given information. You need to use the parallel theorems, the theorem for parallel that we learned, and the congruent triangles, the congruent triangle. So maybe you need to draw DB, this one. You can do this because from Euclid, you can, between two lines, you can draw any line. Between any two lines, between any 2 points, you can draw a line. You can draw a line. So we draw the line DB. Now you need to make these two triangle congruent. True triangle congruent using the parallel theorem. You have parallel lines here. So we let us make this angle 1, this angle 2, this angle 3, this angle 4. We have angle 1 equal to angle 2 from the parallel. They are alternate interior angle. Angle 1 equal to angle 2 from alternate interior angle. Angle 3 equal to angle 4, alternate interior angle as well. And BD a common side. So the two, by using angle side angle, angle side angle, the two triangle are congruent. The two triangle are congruent. And then from the congruent, you can conclude that DC equal to AB, BC equal to AD. And this can be used as a theorem now, that in parallelogram, the opposite sides are equal. In parallelogram, the opposite sides are equal. You can use this as a theorem. Okay, now I need to prove the opposite angle. The one that you used just now, now you can use it after we prove this one. That the opposite angle in parallelogram are equivalent or equal. Are equivalent or equal. So I need to prove that the opposite angle of parallelogram are equal. This is also from using the same congruent. I mean, from here, from this example, after we prove that the two triangles are equivalent, or sorry, are congruent, not equivalent, they are congruent. Okay, then you have angle equal to angle also as well. The sides will be equal to the sides, and also the opposite angle will be equal to the opposite angle. Angle A will be equal to angle C. By the same way, you can prove angle B is equal to angle D, because 1 equal to 3 equal to 4. So just add, you will prove that angle D equal to angle B. Angle A here is equal to angle C from the congruence. After you prove that the two triangles are congruent, what you can conclude, this side equal to this side equal to this side, so opposite sides are equal. Now, opposite angle also are equal from the congruence. This angle will be equal to this one. Angle here, because 2 and 4 is equal to 1 plus 3, so the angle D will be equal to the angle B. Also, the opposites angle are equal. So these two examples can be used as a theorem that in parallelogram, the opposites angle are equal. In parallelogram, the opposite side are equal. Since we prove it now, then we can use it. Definition of equivalent triangle. Definitions of equivalent triangle. We have that two geometric figure equivalent if each figure can be split into finite number of polygon pieces so that all pieces can be separated into congruent pairs. If I have two figures and these two figures are, we say they are equivalent, if I can divide each figure into polygons such that one polygon from here is congruent to one polygon from the other shape. One polygon, the first polygon, I mean, you can divide two polygons or triangles. I mean, some definitions use the triangle instead of polygons. So if I divide the first shape, for example, to 3 triangles or to 3 polygons, then the second shape will be divided into the same 3 polygons or the same 3 triangles. So the first triangle from here will be congruent to the first triangle from here. The second triangle from here will be congruent to the second triangle from here. Then we can say that the two shapes are equivalent. The two shapes are equivalent. Between congruent and equivalent. I mean, do you find out what the difference between two figures equivalent and two figures congruent? Actually, the congruent figures should be equivalent, but the equivalent figure not necessary to be congruent. I mean, if the two figures are congruent, it should be equivalent. But if two figures equivalent, not necessary to be congruent. Okay, actually, the two equivalent figures from definition here, which means that I can divide them to, they are not congruent, but we can divide them to parts. The parts are congruent, which means that the two shape, for congruent shape, they should have the same size, the same shape, the same area, the same volume, the same everything for the congruent case. But for equivalent case, not necessarily they have the same shape, but they have the same area. They have the same area, but not necessarily have the same shape. So sometimes from the same parts, I can make a square and can I make a rectangle if they make the same area. Sometimes, you know, you can find some games that they ask you, we give you 7 pieces, and from these 7 pieces, please make a triangle and make a square from the same pieces, right? So the idea is they have the same area, but not necessarily the same shape for equivalent figure. For congruent figures, they should have the same area and the same shape and the same volume. Everything should be same. So this is the difference between equivalent figure and congruent figure. So if the figures are congruent, for sure they are equivalent. But equivalent figure not necessarily have this are congruent, but they have the same area because we can divide each figure into triangles or polygons that they are congruent to the secant shape. The secant shape also can be divided to the same polygons, but we arrange in different shape. We arrange the parts or pieces in different shape, on different shape. Okay, I hope it's clear. Okay, for this one, for this example, I have a two parallelogram, A, B, C, and D, and another parallelogram, E, B, C, and F. E, B, C, and F. The two parallelograms are sharing the same base, BC. BC as a common side between the two parallelograms. And we have that AF is parallel to BC. AF is parallel to BC. D is a point between E and F. Okay, now I need to prove that the triangle A or EAP is congruent to the triangle FDC. I need to prove that this triangle is congruent to this one. Is congruent to this one. It's angle 1, angle 2, angle 3. It's an angle 4, angle 5, and angle 6. So to make it easy for you to name the angles. Is parallel to, sorry, we have that AF is parallel to BC. This one is parallel. So 1 and 4 will be, also DC is parallel to AB. So 1 and 4 are corresponding. DC from the parallelogram is parallel to AB. So 1 and 4 will be corresponding. And also you have AF parallel to BC. So 2 and 5 also are another corresponding angles. So they are equal. Now look for side. Look for the parallelogram. Yes, the parallelogram. AB equal to DC from the parallelogram here. ABCD is a parallelogram. Then, yes, using the previous theorem or previous example. Now, I have ABCD and EBCF are parallelograms. So from parallelogram, you have this side equal to this side. Actually, you have another, this side is equal to this side as well. That is equal to this side. Now from parallelogram also you have this side is parallel to this one. So 1 equal to 4, 2 equal to 5. 1 equal to 4 and 1 equal to 5. So what you can do is just make the two angles are equivalent. Here, just make the triangles. Now you have angle 1, angles 1 and 2 are equal because they are corresponding. Angles for 2 and 5 are equal. Sorry, 1 and 4. 1 and 4. 2 and 5 are equal. Again, corresponding. DC is equal to AB parallelogram because ABCD is parallelogram. Okay, so what we can conclude is that the triangles AEB and FDC are congruent. Are congruent. So already the triangles are congruent. A, B, E will be equal to DCF. DCF. So they are congruent. Angle A equal to angle D. Angle E equal to angle F. Angle E equal to angle F. Try when you write the congruence, make angle A equal to angle D, angle E equal to angle F, angle B equal to angle C. Try congruent angles corresponding to each other. Okay, so now I have the corresponding angles. These triangles are congruent, and also the two parallelogram are equivalent, and also here you can prove they are identical as well. They are congruent as well, not only equivalent, not only equivalent. Okay. Definitions. A rectangle is a quadrilateral in which all angles defined by the vertices are right angles. Okay, so if I have a rectangle A, B, C, D, we can identify two adjacent sides and call the length of one of the sides base of the rectangle and the length of the other side is height. I mean, rectangle is a parallelogram actually, not only a quadrilateral. It is a parallelogram, but the angles for this parallelogram are perpendicular, are right angles, are right angles. So for rectangle, I have, because each opposite side are equal from parallelogram, so you have two opposite sides are equal and another two opposite sides have different lengths, but they are equal. So one, if you take two adjacent side or near sides, okay, so one of the side will be the length, the other side we call it height. One of the side we call it length, the other side we call it height. If two figures can be made equivalent, we will say that they have the same area for sure. The equivalent figure have the same area, not necessarily same shape, but they have the same area. Okay. If we call one side of parallelogram to be a base side, so what is the height? The height of parallelogram relative to that base side is the perpendicular distance between the base side and the opposite side. This is for general parallelogram. This is for general parallelogram. For example, if I so this is just general parallelogram. Choose one side, call it a base. Choose one side, call it a base. So the height will be the distance from the opposite vertex to this base. This is what we call it the height. This one we call it the height. The definition of the height. So in general parallelogram, if you choose one side as a base, then the height will be the distance between the opposite vertices, the opposite vertex, or the opposite point, the perpendicular distance to that base, the perpendicular distance to that base. So if we define that side of parallelogram to be a base, then the height relative to that base is the perpendicular distance between the base and the opposite side, between the base and the opposite side. Maybe the height can be here also. From any point here, you can draw the height. You can draw the height to the base, height to the base. In the case of the rectangle, because the rectangle is the angles is 90 degree, so the other side will be the height. The other side in the rectangle and square as well. The rectangle and square. Okay, show that the area of the parallelogram ABCD here is the product of the base. So this is another example. We need to show that the area of parallelogram ABCD, this one, is the product of its base AB and its height. And its height. This is how we find the area of parallelogram. We product the base by the height. We product the base by the height. But we need to prove that. To prove this one, I will draw a rectangle. Now I have A, B, C, D. This is a parallelogram. So I will draw a rectangle, okay, equivalent to my parallelogram. Equivalent to my parallelogram. Equivalent means both have the same area. Both have the same area. Okay. Then I will find the area of the rectangle. And using this one, we will assume this is the same area of parallelogram. This is the same area from parallelogram. To a line, to another line. From any point, you can draw a perpendicular line for a line. So from A, I will draw a perpendicular line to DF, this one. And from B, you have a perpendicular line. You can draw, we have these two theorems. From any point, you can draw a line perpendicular to another line or another segment. From A, we can draw a line, or from E, you can draw also a line that is perpendicular to DF. This is the theorem we have. From B, you can draw another one. From D, you can draw another one. Now you have a rectangle. Now you have a rectangle A, B, E, F. You have a rectangle A, B, E, F. Okay, and these two the rectangle and parallelogram are equivalent. How I can know that they are equivalent? We claim that the rectangle and parallelogram are equivalent, which means they have the same area. Go back for the definition of equivalent figures. To be sure that two figures are equivalent, you need to divide the two figures into polygons or into triangles that are congruent. Okay, AD, yes, the two triangle ADA from the previous example, actually, the two triangles DEA or ADE is equivalent to BCF. These two triangles are equivalent. These two triangles are equivalent. But the question is, this is not enough to make it. I need to divide all the polygons. But so I can draw like this rectangle, many rectangle. I mean, I can draw this one. I can again repeat the same rectangle. Sorry, the lines. After you prove that the two triangles are equivalent, so the same rectangle here can be divided to these triangles, like this. But okay. And also the parallelogram by the same way. For congruent triangle here, you can still divide also the parallelogram. So we can divide the rectangle into triangles, into number of triangles, and also the parallelogram to the same number of triangles, and these triangles are congruent to each other. These triangles are congruent to each other. This is why the rectangle is equivalent to parallelogram. Since they are equivalent, they have the same area. They have the same area. And the area of the rectangle is side by height, base by height. So this is will be the same area for parallelogram. That's the base by height. The base by height, same. So two equivalent figure means that the two figures have the same shape, sorry, the same area, but not necessarily the same shape. But if they are congruent, they have the same area and the same shape, so they are equivalent. But equivalent shape, not necessary, because for now, just example, I have a rectangle and parallelogram. They are equivalent, but they are not congruent. They are equivalent, have the same area, but not congruent, because this is a rectangle, this is a parallelogram. So we have a difference. Theorem, now I need to find the area of right triangle, which means a triangle that have right angle. The triangle that have right angle. This is a theorem. I didn't write the proof here because the proof should be clear. Proof that these two triangles are congruent. So the area will be half of the area of rectangle. The area will be half of the area of rectangle. Okay. The area of any triangle. Now here we prove that this is for right triangle. That triangle, right triangle means that a triangle that have right angle. Okay, if I look for any other triangles, the area of any triangle, not necessarily the triangle that have right angle, it will be the product or half of the product of the base of the triangle with the height of the triangle. With the height of the triangle. This one concludes if you have any triangle, not necessary be a right triangle, then just draw a height. So we call this one base. So the area is the half of the product for base and height. For base and height. For base and height. Because actually you have two right triangles now. You have two right triangles. So you can use this one. Or you can use also the rectangle, but you can use this one directly because from rectangle you will go for this one. So you can use this one directly because when you draw the height, you have now a triangle with right angle and you have another triangle with right angle. Okay, so this one is 1/2 base times height. This one 1/2 base times height. So just add, you will have, it is half the base of the height. This is concluded directly from the previous theorem. And the definition here before going to similar triangle is a median of a triangle. The median of triangle. The median of a triangle is the segment from the midpoint of a side to the opposite vertex. The median of triangle is a segment from the midpoint of a side to the opposite vertex. I mean, if I have a triangle, then take the midpoint and draw a line from midpoint to the vertex. We call this one is a median. We call this one is a median. Call this one is a median. So now you have, don't confuse between the median and the altitude and the bisector perpendicular. Okay, because when we define the circumcenter, we draw from the midpoint perpendicular line, not necessarily go for the opposite vertex. We draw from the midpoint perpendicular lines. These lines intersect in one point. We call it circumcenter. For orthocenter, we draw the altitude, which means that the line from the vertex perpendicular to the opposite side. And for going to the incenter, we are bisect the angles. We are bisect the angle. Now for the median, we bisect the length, but we draw a line from this midpoint to the opposite vertex. We call this one as the median of the triangle. And these median are intersect also in one point. Also intersects in one point. Any question? Angles, which means that they are not congruent, they are similar to each other, but not congruent to each other, not congruent to each other. Okay, when we can say that the two triangles are similar, if the three angles are equal, if the three angles are equal. The triangle are similar if and only if there is some way to match vertices of one to another such that the corresponding sides are on the same ratio and the corresponding angles are congruent. So for the triangles, if you have sides with two angles, they are congruent. If you have three sides, they are congruent. If you have two angle and one side, they are congruent. If you have one, at least one side, they should be congruent. They should be congruent. But if the sides are not equal to each other, but the angles are equal, the corresponding angles are equal or congruent, then we say that the two triangles are similar. So the triangles ABC is similar to the triangle XYZ, and we note the similar like this one. This is the notation of similar. This is the notation of congruent, but this is notation of similar. So the triangle ABC is similar to the triangle XYZ if and only if AB over XY, if I take the side AB with the corresponding side XY, then the ratio between AB over XY will be equal to the ratio between AC and XZ, equal to the ratio between BC and YZ, equal to the ratio between BC and YZ. So the ratio of corresponding sides are equal, but the sides not equal. The ratio between them is equal. And the angles are equal. The angles are congruent or equal. The angles BAC equal to the angles YXZ. The angle CBA equal to the angle ZYX. The angle ACB equal to the angle XZY. So the angles are equals. The angles are equal, but the sides not equal, but the ratio between them is equal. The ratio between them are equal. In this case, we call that the two triangles are similar. The two triangles are similar. So here, suppose that I have a line parallel to one side of a triangle and intersect the other two sides. I have one line parallel to another line and intersect the other two sides at different points. Then this line will divide the intersected sides into proportional segments. I mean, if I take the line L, I draw it parallel to BC and intersect the other two sides. Now, this line will divide the side AC into two parts and the side AB into two parts. So we claim that the two parts are proportional. The two parts are proportional. Means that if I take that BD over AD, it should be equal to EC over AE. Or AD over BD should be equal to AE over EC. Proportional segments. So how can we prove that? I will use the parallel theorem and also the area of triangle, because now we know how to find the area of rectangle, how to find the area of parallelogram, how to find the area of triangle. So take the line L is parallel to BC and the triangle ABC. Now L will intersect the side AB at the point D, the side AC at the point E here. This is a given information. This is a given information. Now I need to construct a perpendicular from point E to AB, from point E to AB at the point F. This line, I will draw it perpendicular to AB. We can do this because we have a previous theorem that from any point you can draw a perpendicular line. From any point you can draw a perpendicular line. So EF will be perpendicular to F. This one, I draw it. We can do this from previous theorem, Now consider the ratio between the triangle BABED, this one, BED, and AED, BED and AED, these two triangles. Okay. Now the first triangle, BED, will be 1/2 times the base. The base here is BD, and the height is EF. The height is EF. Okay, for the triangle BED, if you need to draw the height from E to AB, it would be EF. So this is the height of the triangle. So the area of the triangle, 1/2, the height times the base, which is BD. Okay, for the second triangle, AED, same. 1/2, the base, which is AD, times the height, which is EF, Now cancel EF with EF. You can cancel EF with EF, 1/2 with 1/2. So you have BD over AD, BD over AD. This is the first one. Okay. Now again, I will repeat what I did, but this time I will not draw the line perpendicular to AB on F. I will draw from D. I will start from D, exactly the same steps. But I will go for point D, I will draw a perpendicular line to AC. A perpendicular line to AC, this one. And then you take the ratio between the area for ECD, this triangle, and AED, this triangle. So the ratio here will be, okay, the area CED will be 1/2, the base, which is CE, and the height, DG. For the rectangle ADE, also same. The area is 1/2, the base, which is AE, times the height, which is DG. This is the height that I draw. This is the height that I draw. So you can cancel DG with DG, the height. 1/2 is 1/2. Then CE and AE. This is the second ratio. The area for these two triangles is equal to the second ratio. Now look for the triangles BED, because BED and CED. BED and CED. Look for these two triangles. BED, CDE, these two triangles. For these two triangles, they share the base DE. They share the base DE, right? So since they are share the base, so the height will be same. The height will be same. We can drop the height to DE from the point to another line to DE, which means that these two triangles have the same height and the same base. From the same height and the same base. What we do like that, because since the area of BED and AAD equal to the area of CED, because if they have the same base and height, they have the same area. They have the same area. So look back again here. I have this triangle BED over AED. The second one CED over the same triangle AED. Okay, so the triangle here same AED for the both ratio AED same. But here I have the triangle BED. Here I have the triangle CED. So if I can prove they have the same areas, then I can make that the ratio will be equal to the previous ratio. So here what we prove that the area BED equal to the area CED. Equal to the area CED. This one. Why? Because these two triangles are sharing the same base and the same height. The same base and the same height. So the ratio, this one we proved it is equal BD over AD. This ratio we already proved CE equal to AE. So this is what we need to prove. BD over AD is equal to CE over AE. So if you have a line that is parallel to another line and intersect the sides in 2 points, then it will be divide the sides into proportional area, which means that BD over AD equal to CE over AE. What we did, we have go first, we draw from E a line perpendicular to AB, and then this line will be the height, the same height for these two triangles. The same height for these two triangles. So the area for this one is 1 over 2 BD times height. The area of this triangle is 1 over 2 AD for the same height. So just cancel the heights and 1 over 2, so you have the ratio BD over AD. Now similar for the second side. I will draw from D another line. I will draw from D another line like this, perpendicular in point G. Then I have the triangle ADE with the triangle DEC. They have the same height but different base. So you just, the area of CED will be 1 over 2, the height over the base EC. The area for ADE is 1 over 2, the height or times AE, the base. So just cancel the height with the height, 1 over 2 with 1 over 2, then CE over AE, CE over AE. So now you have these two ratios. I need to prove that the areas here, that the area over this area is equal to the area over this area. I have the same triangle in the denominator here, but the above triangle is different. Here I have BED, here I have CED. So what the relation between BED and CED? These two triangles have the same base and the same height. Have the same base, and for sure, because they are between two parallel lines, they have the same height. They have the same base DE, and you can, for each triangle, draw from C a height for DE, draw from B a height for DE, so the height is same because the lines here are parallel. The lines here are parallel. So the area for both are same. Since the area of both are same, then the two ratios are equivalent. So PD over AD and CE equal to CE over AE. And we can conclude that AB over AD equal to AC over AE. AB, the bigger one, over AD is equal to AC over AE. It can be concluded directly because AB is equal to AD plus DB. AC is equal to AE plus AC. So just AB is AD plus BD, okay, over AD. This is 1 plus AD over AD is 1 plus BD over AD. And this ratio from here is equal to CE over AE. So I can write 1 here is AE over AE. So AE plus CE is AC. So this is can be concluded directly. This is can be concluded directly. Any question?